Welcome, ladies and gentlemen, to our online lecture about physical changes and state transitions as an example of physical change. So far this unit, we've started out by identifying some physical properties of matter. So we are now going to start moving into physical changes, which will then follow up with chemical properties and chemical changes. So we already know a little bit about physical properties as characteristics we can record or measure about a substance without changing what it is. We're going to see some similarities in those changes in that definition of physical property. So when something undergoes a physical change, it doesn't change its chemical makeup. It stays the same substance. The change will be related more to appearance or form. So a great example of this would be ice transitioning between its states. A block of ice has H2O molecules within it with very low energy, and they're in the solid state. When I add energy, the water will become a liquid form, but it's still H2O molecules that are making up that substance. And even in adding more energy to transition it to a gas, it's still water molecules. They're just much more spread out and have much more energy associated with the particles. Now, when we see these types of changes occur, some of your extensive measurements will change. So when I go from ice to water, I actually decrease the volume. Ice is unique in that the solid form is less dense than the liquid form. When I transition from a liquid to a gas, it will become a much greater volume for the same amount of particles. So the spacing between the particles will change, leading to changes in volume or things like that. So what are some examples we have of physical changes? Something like cutting a material, sanding will break it up into little particles, but it's still the same material. Heating, cooling, bending, filtering, mixing, and dissolving. Think about that Kool-Aid that you make. When you mix in the flavoring with the sugar, all the materials are still there, they're just in a different arrangement. So we still have sugar, we still have all the dye materials, it's just they're dissolved within the solution. One way that we classify these physical changes is based on whether they're reversible or irreversible. So a phase change would be the same thing as a state change. When I transition between solids, liquids, and gases, changes in energy can reverse those types of changes. So even if I melt an ice cube, if I put that water back in the freezer, I can get it to turn back into the ice state. So those would be classified as reversible because I can go back and forth. And again, the big difference in state changes is about changes in energy of the particles. The material itself doesn't change, just the energy. So we give special names to these different transitions to classify what state change is occurring. And one of the things you'll be assessed on is your ability to recognize that in a graphical representation of changes in temperature while heat is being added or removed. So our first transition is really the same transition, it just depends on where you're going. So if I'm melting, I'm going from a solid to a liquid, and that is going to involve adding energy. The particles have to be sped up. If I have a liquid going to a solid, energy has to be removed, and that will slow down the particles. So notice that as you add heat to the solid state, there is a change in temperature. We recognize that by the fact that there is a positive slope in that section of the graph. But then during the transition, the temperature is not changing. So the particles at this point are not actually speeding up or slowing down. They are gaining enough energy to disrupt the attractions between the particles, or reform the particles between the attractions between the particles. So the gain in energy is going to the change, if I'm melting, the gain in energy is disrupting the forces of attraction between those solid particles. And then when there's enough to disrupt the forces, they transition to the liquid, where again we then see the temperature change occurring from the slope in the graph. So with each of the transitions, what you will be responsible for understanding is what is the change in energy and how does that affect the substance itself. So if the particles are changing their speed, that would be a change in kinetic energy, the energy of motion. If we're looking at a change in the positioning of the particles as we're increasing or decreasing the forces of attraction, that's more positional or potential energy changes. Make sure that you reference kinetic and potential energy in your notes. That is going to be my item that is spoken but not written. So our next set of transitions involves liquids and gases. We have two different ways that we can transition a liquid to a gas, and it's very much about the quantity and the temperature at which you're at. So energy does have to be added in both cases. But in evaporation, that's more like a puddle on the sidewalk. That puddle is not going to reach boiling point. But within a liquid, there's an average speed of the particles, and some are moving faster and some are moving slower. So those particles that have enough energy to break those forces of attraction at the surface of the liquid are then able to transition to the gas state. With vaporization, we will get that substance to the boiling point temperature, and that's where an entire liquid or a large quantity is going to change state. So it's about how much of the substance at which temperature we get to. Going the other direction, in removing energy, condensation is when we go from a gas to a liquid. In our last set, we have the ones that skip a state. So sublimation would be when you go directly from a solid to a gas. So that energy state where it exists in a liquid is such a small range of temperatures, it goes right to the gas state directly from the solid. A great example of this is dry ice. So dry ice, which is carbon dioxide in the solid form, will transition directly to the gas state. Deposition would be when a gas goes directly to a solid and skips the liquid phase. This could be snow forming in clouds. Sometimes you might have some water vapor in the air, then get on a frosty window in the winter, so sometimes that's an example of deposition. But again, the energy change is drastic and quick, and we see that deposition going directly from the gas state to the solid state. As you wrap up your notes and really think about these transitions, the next step is that you're going to work in class on some graphing activities, looking at the data and analyzing those different regions of the heating curve that we see here. So the graph here is called a heating curve, and if we would put actual temperatures on the y-axis, we can connect those to specific types of substances. And that goes into another example of physical properties we can define for a given substance. So make sure that you have recorded this in your table of contents, and that you've identified what objectives this connects to, and when you finish, you'll be able to transition into our classwork on analyzing heating curves.